Living in space is hard. The space station keeps astronauts in comfortable living conditions. But what if you want to go outside and take a look around? Well, this won't work. To survive, you'll need a spacesuit. In a very real sense, this is a human-shaped spacecraft, just big enough for one person. In this video, we'll break down how spacesuits work by looking at the current ones that NASA uses on the International Space Station. And you'll even get a chance to see me put on one of these suits. Then we'll take a quick peek at the next generation suits being designed by a private company. Let's go back to the scene from earlier, stepping into space without a suit. What would happen? Our bodies are used to the conditions here on Earth. There's air to breathe, pressure on your body from the atmosphere, just the right temperature, not too hot, not too cold, and our atmosphere protects us against radiation and micrometeoroids. In space, you've got none of these things. You would lose consciousness in seconds and survive maybe a few minutes. That's why astronauts need spacesuits. Our one-person spacecraft provides oxygen, maintains pressure, keeps the temperature comfortable, and protects against the dangers of space. The challenge is creating suits that are also flexible enough to do complex tasks in space. NASA started building spacesuits in the 1960s. With each space program, they improved upon the suits, adding extra protection and even the ability to walk on the moon. Then came improved spacesuits for the space shuttle, and this spacesuit is still in use today. Commercial space companies are creating their own suits that are sometimes used by NASA, and there will also be 2 new spacesuits for the Artemis missions. We'll take a look at the AXEMU towards the end of the video. Some of these suits are meant to be worn inside the spacecraft. We call these IVA suits. And the suits meant for going outside, these are called EVA suits. You'll notice some of these suits fall under both categories. EVA suits have a lot more protection and they can work outside in space for hours at a time. Whereas IVA suits only have enough protection just in case of an emergency. For this video, we'll focus on an EVA suit that NASA is still using today. The EMU spacesuit. It is a NASA spacesuit, but it was designed and built by other companies. The suit has been used for more than 40 years now. It'll be a good example of how the different parts of a spacesuit work in general. There are 2 main parts: the pressure garment system, that's shaped like a person, and then the PLIS, the Portable Life Support System, also called the Primary Life Support System. This is what keeps you alive inside that shell. The pressure garment itself is made of around a dozen layers, much of it sewn by hand, that work together to hold pressure, protect, and allow the astronaut to move. Before even getting into the suit, astronauts have to wear a few things. They start with a MAG, or maximum absorption garment. Yes, basically an adult diaper. When you're sealed up in a suit for up to 8 hours, you have to go somewhere, but don't think about that too much. Then they put on the LCVG, or liquid cooling ventilation garment. It has nearly 100 meters of tubing to circulate water against the astronaut's body. The suit will trap heat, so this is the secret to keeping them cool throughout the spacewalk. Now the layers of the actual spacesuit. Each layer has a very specific purpose. First is the pressure bladder. It's a tough fabric sealed with a rubbery coating, almost like a balloon. The restraint layer is like a tough woven fabric you'd find on a backpack. It supports the loads for the bladder. The bladder and restraint are carefully shaped to allow the joints to bend in a specific way. Think of it like one of those bendy straws you would use in your drink. The rest of the layers are part of the thermal micrometeoroid garment. This is the liner. This is like the thin material used on a camping tent. It will protect the next layers of the suit from wear and tear. Next are multiple layers of insulation. This resembles tinfoil but can withstand extreme temperatures, keeping it much more comfortable for the astronaut. The outermost shell is the ortho fabric, made from some of the same materials used in bulletproof vests. It's the final layer of protection in the spacesuit. With all these layers, you can get an idea of why it's so hard to move inside the suit. The suit is white because this color reflects the sunlight and helps keep the temperature comfortable for the astronaut. The EMU spacesuit was first used on the space shuttle, but then later upgraded to use on the ISS. While pressurized garments get updated, the PLIS backpack remains the same. Only 18 were ever made, each costing up to $150 million in today's dollars. Only 11 of them are in use today, with about 4 at a time used on the space station. You can think of the PLIS like a well-maintained vintage sports car. Old, but still works great. As you might guess, it's about time for an upgrade. Let's take a closer look at the inside of the suit. The hut, or hard upper torso, is made of fiberglass. It's a hard shell with lots of other parts attached to. If the astronaut needs a drink of water, they can use the simple drinking bag with a straw. This is attached to the front of the hut. On the outside, there are some connection points. This is where we attach the mini workstation, which is like an astronaut's tool belt. The arms attach to the sides of the hut. On each side, there's an upper arm and a lower arm. And they have different sizing options to fit different body types. The straps on the side are adjustable to make sure the suit fits just right. The joints in here have bearings. What that means is that they can rotate. If we take a look inside one of the joints, you can see the parts that allow this to rotate. And at the same time, keeping the suit airtight to maintain pressure. Astronauts have to do what's called programming. It's getting used to the way that the joints work. They have to move in specific patterns to avoid using too much energy. The gloves attach at the very end, but we'll see this later on in the video. On the front of the hut is the display and control module. It's like the control center for the suit. If you look closely, the text on the control box is mirrored. That's because an astronaut can't see it when fully suited. The solution is to put a small mirror on their wrist. That way they can see the numbers and make suit adjustments. Next is the lower torso assembly. This has a hard metal ring at the top called the body seal closure. This is what connects to the hut. Then 2 more ring connections down below. The waist has bearings to allow for some turning, but other than that, there's not much movement in the lower torso assembly. Putting on the spacesuit is a lot of work. I had the chance to visit NASA and actually put on an EMU suit. I needed a lot of help to get inside and connect the different pieces. The full spacesuit weighs about 275 pounds here on Earth. This is part of the reason why they wouldn't let me walk around in it. Let me now show you the process of getting into a spacesuit. The astronaut first puts on the mag, and then the LCVG. We saw these earlier in the video. Then they get inside the lower torso, often called the most expensive pants you'll ever wear. The upper torso is usually mounted to a stand or airlock wall. It's a tight fit and usually takes some practice to get into. Someone nearby will connect the LCVG. This is how the water will flow to cool the astronaut. The astronaut cannot reach the lower torso, so with a little more help, the 2 halves will be sealed together with the body seal closure. The astronaut will next put on the communications carrier assembly, sometimes called the Snoopy cap. It has microphones and speakers so they can talk with other astronauts and mission control. Next are the gloves, which connect just above the wrists. This has another bearing that allows the glove to rotate. Here's an image of the ortho fabric on the outside and the restraint layer on the inside. The joints have to be flexible enough to allow the fingers to bend, and heaters at the tips to keep the fingers warm. All that's left is the helmet. It's actually made of several different parts. The helmet bubble is shatter resistant, which means it would be very hard to put a crack in this. It's just big enough to fit a head inside. I hope you aren't claustrophobic. Attached is the visor assembly. It has a protective visor in front. This is locked into place. Then during spacewalks, they can bring down the gold-coated sun visor and eye shades to protect from the sun. On top are cameras and lights. The helmet is fixed in place with no bearings, which means it cannot turn to the left or right. They can still turn their heads inside, but to get a really good look, the whole upper torso will need to turn. Finally, we have the Pliss. There's a lot of parts in here. Let me just highlight some of them. There are several batteries to power the suit's system. Primary oxygen tanks provide air to breathe, and secondary tanks as an emergency backup. Up here, you'll find special canisters to remove carbon dioxide from the air. Inside, you'll find water tanks, which are used to send water throughout the suit to keep it cool. This includes the LCVG, the liquid cooling ventilation garment that we saw earlier. A fan and pump motor circulates air and water throughout the suit. The sublimator turns frozen ice into a gas to vent into space. This gets rid of some of the heat. These are sensors that monitor equipment and can warn if something is wrong. And a radio and antenna for communications. All of this is in a small package that has to work flawlessly for up to 8 hours at a time. We're going to take a look at actually doing a spacewalk and what could go wrong. But first, let's talk about what it would take to design a spacesuit like this. You'd have to think critically and have a deep understanding of how things work. If you want to level up your skills, Brilliant.org is the perfect place to start. Brilliant is a learning app that teaches you to think like an engineer, to solve challenging problems step by step. Don't get me wrong, watching videos is a great way to learn, but the next step is to actually do it. With Brilliant, you can understand why things work the way that they do, not just memorizing facts. You can try thousands of interactive lessons in math, science, programming, data analysis, and AI. For example, this course shows you how electricity works. You can understand the terms and what the symbols mean. I've enjoyed refreshing on math concepts that I learned in school, understanding things in new ways that I've never seen before. Brilliant helps you level up your skills for wherever the future might take you. To get started for free, go to brilliant.org/JaredOwen. And when you're ready to upgrade and get unlimited daily access, my viewers can get 20% off the annual premium subscription. On the ISS, when they do a spacewalk, it's called an EVA. It takes several hours to get prepared for it and get completely suited up and ready to go outside. The astronauts go in pairs for safety. They use multiple tethers to stay attached to the station. In the unlikely event that they become detached from the station, it would be impossible to get back on their own. That's why they use SAFER, the simplified aid for EVA rescue. It has a small jetpack with just enough fuel to maneuver back to the station. But luckily, it's never been used in an actual emergency. The EMU spacesuit has limited mobility in the legs. Most of the work is done with the upper body. Remember, the EMU spacesuit is not meant to walk on the moon. That's what the Apollo spacesuit was meant for, and even then, it was a bit clumsy, and getting up from a fall was incredibly difficult. When astronauts return to the moon, we'll need a new spacesuit to be able to walk around on the surface. There is a government reference design called the XEMU. It's based off of decades of research from NASA and other companies that NASA's worked with. But now, a company called Axiom Space has been chosen to take the design and build the final version, called the AXEMU. This is the suit that will be used for the next moon landings. You might have seen pictures of the suit in these colors, but once it's in use, it'll be white to reflect the sunlight just like the other suits. The helmet shape allows for a wider range of view, and the gloves are designed for easier movement. The suits are much more flexible, which will allow the astronauts to crouch or kneel to collect samples. The Bliss has newer technology that will allow for longer spacewalks. Putting on the suit is a lot different than before. The AXEMU opens from the back. Then the astronaut can climb in feet first. This will be easier and faster to get into than before. In the end, a spacesuit is more than just clothing. It's a personal spacecraft meant to keep you alive in the vacuum of space. My name's Jared. Watch another space video by clicking here. And thanks again to Brilliant for sponsoring this video.